Okay, so in this video we're going to be looking at graphs of motion. Not the most exciting thing in the world, but definitely necessary. So the first graph that we're looking at is distance versus time, and the second one that we're going to look at is speed versus time. So time is always going on the x-axis, and the other two are going on the y-axis. It's important when you're doing questions about graphs that you double check and see what is sitting on the y-axis, because they actually tell you two different things. Okay, so the first graph that we're going to look at is a graph that has a straight horizontal line on it. As you can see, as the time is increasing, we're actually not moving. It's at the same distance this whole time. So this graph indicates that the object, in this case, is actually at rest. It's not moving, it's not going anywhere. Time is elapsing, but it's not actually moving anywhere, as indicated by the fact that it's a straight horizontal line. So this graph that we're looking at now indicates that as time is elapsing, the distance is increasing in a similar kind of fashion. This is what we call constant speed. It's not that the speed is increasing, it just means that the object that the graph is representing is moving at the same speed over time. If, for example, I was to include a second line, like this, the red line is actually representing still constant speed, but at a higher speed than the blue line, than the object that is represented by the blue line. So, as you can see, they both arrive at pretty much the same point, the same distance, but the red line, or the object represented by the red line, reaches that distance in a smaller time than the object that is represented by the blue line. This is just showing higher speed. It's still constant speed, but just at a higher speed. So, say for example, this could be 50 kilometers an hour, and this one might be 75 kilometers per hour. I'm just making that up. That's not actually real. Okay, so this is the last distance time graph that we're going to look at. As you can see, the line here is not straight, so we're not looking at constant speed. What we're looking at here is an increase in speed. So what this is actually showing is acceleration. So, in other words, over time, the distance the object moves is getting larger. It's changing at a faster rate. So here it's a bit low and flat, and then we suddenly go up and increase. So this is showing that this object is actually accelerating. Now, of course, we've just looked at objects travelling at a constant speed, but if you see that an object, if you see that the graph of an object has a line that is downward sloping, this is still constant, but it's showing a constant decrease over time, a decrease in distance over time. This shows you that the speed of the car is decreasing. Similarly, if you saw a graph that was if you had a line that was steeper than the original line, that would show you that it's decreasing in speed at a much faster rate. Okay, so moving on to the second type of graph that we were going to look at. This one is a speed time graph. It can also be called a velocity time graph. When you're looking at a graphing question, make sure you double check what is on the y-axis, because you can't read it in exactly the same way that you read a distance time graph. So on a speed time graph or a velocity time graph, a straight line doesn't indicate that the object is not moving. What it means is that speed is constant. So straight lines are still indicating some form of constant change over time. So an object that has the speed-time graph where the line is upward sloping shows an increase in speed or acceleration. So upward sloping line on a speed-time graph means acceleration. And then when you have the downward sloping line, this means that we have deceleration. And again, like the distance time graphs, the steeper the line, the greater the acceleration or the deceleration. So here, the blue line is indicating that the object represented by the blue line is decelerating at a faster rate or has greater deceleration than that of the object that is represented by the red line. It does not mean that the deceleration is not constant. It's steady deceleration, just at a faster rate. The way that we would actually indicate if an object was not moving on a speed-time graph would be like this. So, no speed over time, which means that the object is stationary and the object is not actually moving. So in the exam, we expect that you're going to be able to read these graphs. So for example, if I say this is 10 seconds, and I say in the question, I want you to find out what the speed of the object is at 10 seconds, I expect that you'll be able to go, okay, so 10 seconds, line here, oh look, it's 5 meters per second. We expect that you are able to do things like that. Okay, the last thing that I'm going to talk about in this video is the concept of weight versus mass. This is another formula that you might need to know, or at least covers a concept that you might need to know. So mass refers to the amount of stuff that's in an object. It's the amount of matter that's in a certain object. We normally measure mass in kilograms. The difference between mass and weight is that weight is a measurement of how hard gravity is pulling on that object. And weight is actually, it's actually a force. So we measure weight in newtons. And the way that we calculate weight is W equals mg. And g is acceleration due to gravity. On Earth, g is 9.8 meters per second squared. G changes according to where you are. So for example, if you're on Mars, your weight will be different than if you were on Earth because it's got a different acceleration due to gravity. The way that gravity is, or the amount that gravity is pulling on you is different on Mars as it is on Earth. So weight changes according to where you are, whereas your mass, or the amount of stuff that you are made up of, is constant. It doesn't change. This also means, so weight equals mg, also means that mass equals weight divided by gravity. And if by some chance you needed to find out what acceleration due to gravity was on a particular place that wasn't Earth, you could do gravity equals weight divided by mass. So gravity, acceleration due to gravity, we measure in meters per second squared because it's still acceleration, but it's due to gravity. It's just an extra bit. Mass, kilograms. And remember, because weight is a force, we're measuring it in newtons.